Alright, so we've got today's notes here. So the first problem we have says the monthly average water temperature of the Gulf of Mexico and Key West, Florida varies during the year. In January, the average water temperature is 69 degrees Fahrenheit. In February, it's 70 degrees Fahrenheit. In March, 75 degrees Fahrenheit. And in April, 78 degrees Fahrenheit. So how can we represent this relation in 4 different ways? So the first way is just by making a list. So we're going to say that for January, our water temperature is 69 degrees Fahrenheit. In February, our water temperature is 70. In March, we got a water temperature of 75. And then in April, our water temperature is 78 degrees. So that's our first way to represent this relation. Another way is to make a table. So we know that when we make a table, we've got an x and a y axis, an x and a y. So an input and an output. Our input is the month, and then our output, the y, is the water temperature in Fahrenheit. So the month, we know that we number our months. So 1 would be January, 2 February, and so on. And then we have our water temperatures listed already. So we've got 69 degrees, 70 degrees, 75 degrees, and 78 degrees. So we have a list, we have a table. From a table, it's easy to go to a graph. So from the graph, we're going to need to make sure that we have an x and a y axis. So we had an x and a y here, which were our input and our output. We're going to have an x and a y here. It's going to be our axis. So again, our months are the x, and then our water temperature in Fahrenheit is going to be our y. So I'm not going to make a very accurate graph. We've got 1, 2, 3, and 4. And then we'll say that this is 60 and this is 80. So all of our numbers are going to be somewhere in between. So for our first month, we're at 69. For our second month, we're at 70. Third month, we're at 75. And then fourth month, we are at 78. So we could make a graph to represent this relation. Or another way that we could represent the relation would be to make points. So with our points, we're going to use coordinates, whatever you want to call them. We're going to use our x and our y. So we can look back at this table. We've got 1, 69, 2, 70, 3, 75, and 4, 78. So these are 4 different ways that we could represent the relation. So here, this should be separated. We've got this list of points. So we've got this set. So anytime you see this right here, it's called a set. And we've got our questions here. We say the domain and the range. So just a refresher, domain is all of our x values, our input values. So all of our input values, we're going to list them to make our domain. Oops. Sorry. We're going to list them to make our domain. So -3, 0, 2, 9, and 23. So that's every single time we had an x. And then our range is all of our y values, or output values. So we'll make another set. And now we're just taking all of our y's. So every second number is going to be in our range. So we have 14, 7, 0, negative 18, and negative 99. So then it says, is the relation a function? So here's the key question. How do I know? How do I know when something is a function? We know that a set is a function, so any relation, this is a relation, is a function when our x values do not repeat. Our y values can repeat over and over and over again, but our x values cannot repeat. So in this problem, we look back at the domain. So no repeated values in the domain is what we're looking for. We have negative 3, 0, 2, 9, and 23. So is the relation a function? Yes. Where's page 2?